Hi everyone, today's topic is how to solve equations with variables on both sides. Here are the steps below. There are three main steps. Make sure that they are in your notebook. The first step is to combine like terms on each side of the equation. So meaning if they both are x's, or if they both have y's, or if they both are constants, you're going to combine them together to simplify them first. The second step is to use your inverse operations to move the variables on one side of the equation and your numbers on the other side. So there's no right or wrong answer here, just move them on opposite sides of the equation. I have one tip. I like to move my smaller values and join them with my larger values because I find that it helps me avoid negative numbers. And we'll talk a little bit more about that later. And lastly, once you have that set up, you basically have a one-step or a two-step equation, and you can solve the equation normally. So as a reminder, if you have like terms that are on the same side, you can add or subtract them like normal to combine them. And if they're on the different sides, then you need to use inverse operations to balance the equation. All right, let's take a look at an example. So here's our first example. 8 minus 4s equals s plus 13. So in this equation, we have variables on both sides. I have s's on the left-hand side and I have s's on the right-hand side. So remember that our first step is to combine any like terms on each side. So meaning I'm just going to look at the left-hand side. 8 minus 4s. Are there any like terms that I can combine here? The answer is no. There's nothing here I can combine. So the first step, sometimes you just can't do it. Okay, let's look at the right-hand side. S plus 13. Can I combine anything? No, again, can't combine because I have s, and for this term I don't have any s's. So they're not like terms. That's okay. We just want to combine any like terms if there are any to make our life easier. Okay, so let's move on to the next step then. The next step is to move all my variables on one side and my numbers onto the other side, my constants. Okay, and remember my tip was to move the smaller variables or the smaller values, whether it's a variable or a constant, to meet the side that has the larger value. So here's an example. I have a negative 4s on the left-hand side, and I have a positive 1s on the right-hand side. This one right here is smaller, the negative 4s, because it's a negative 4. And this one right here is larger because it's a 1. Negative 4 is smaller than 1, right? So I want to move my negative 4 to meet my 1 by adding 4s to both sides. Okay, so then I would end up with 8. These cancel because negative 4s and a positive 4s cancel each other out. They're opposite signs. And this is a 1s plus 4s, which is 5s, plus 13. Okay, so the whole point of it was to make my s's join together because I have s's on both sides. I have negative 4s on the left-hand side and I have a 1s on the right-hand side. So the whole point is to get them on one side so we can start simplifying and then at the end get an answer where it's just s equals something, because right now we have them on both sides. So I worked on my negative 4s and moved it over to the right-hand side by adding 4s to both sides. Now you're probably thinking, well, what if I don't want to follow your tip, Miss Sun? Would it be wrong? No, it wouldn't be wrong. I'll just show you what it looks like. So if instead of moving my negative 4s by adding 4s to each side, if instead I wanted to do the opposite and subtract this s on this side so that s minus s cancels out, I can do that as well. I would have negative 4s minus an s, which would be a negative 5s, equals 13. So you see how I have a negative answer now? I have a negative or a minus 5s. Well, if I did it the other way, I have a positive 5s on the other side. So I just like to avoid my negatives because I feel like I'm prone to making errors when I have negatives because I just know negatives are not like my strength or anything. So I'm going to add 4s to both sides so that it cancels, get 8 alone, and then this will be 1s plus 4s, which is a positive 5s plus 13. And it just looks so much better to me. Again, it's not wrong to do it the other way. My variables will just be flipped on the other side, which is fine. I'll still get the same answer, but I just work with positive numbers. Okay, so if I'm following through with this first step, now I have my s's on the right-hand side. So actually, at the end, I'm going to have my s on the right-hand side. So my answer is going to look like this at the end, which is also okay. It doesn't matter what side it's on. Okay, so I'm going to not touch my s's anymore. I'm just going to focus on my numbers now. If my variables are on the right-hand side, I must move my numbers to the left-hand side. So I'm going to subtract 13 because this is a plus 13, both sides, so that my numbers will join now on the left-hand side. 8 minus 13 is negative 5. Looks like I couldn't avoid negatives anyways, but hey, I tried. Okay, so 8 minus 13 is negative 5 because different signs I'm going to subtract. So 13 minus 8 is 5 and keep the sign of the bigger number, the negative. Okay, now this is 5 times s, so the opposite would be to divide by 5, a positive 5. So those 5's cancel, I just get s on the right-hand side. Negative 5 divided by positive 5 is a negative 1, because a negative divided by a positive is a negative. So my answer is s equals negative 1. I want to check that. So instead of 8 minus 4 times s is 4 times negative 1 equals s plus 13. S is negative 1 plus 13. So I have two different locations to substitute for s equals negative 1. Let me do the math here. 8 minus 4 times negative 1. Well, negative 4 times negative 1 is positive 4. So it becomes 8 plus 4. Negative 1 plus 13, different signs subtract. 13 minus 1 is 12. Keep the sign of the bigger number. Yep, that's positive. 8 plus 4 is 12. 12 equals 12. That checks out. S is indeed equal to negative 1. Lots more steps in these problems, right? Take a look at example 5 from your book. Solve the equation 2x minus 3 equals 7x minus 18. So go ahead and pause the video, try it on your own first. Okay, so again, the first step is to combine any like terms you see on each side. So let's look at the left-hand side, 2x minus 3. Can we combine those? No, we can't, because one has an x and one doesn't, so we leave it alone. Can we combine anything on the right-hand side? 7x minus 18. Again, no, because one has an x and one doesn't, so we leave it alone. Don't do anything for step 1. Sometimes we might, though. All right, so now we got to move stuff, and I'm going to move my x's first. That's just what I like to do, but you don't have to do that. I'm going to move my smaller x, which is 2, compared to my 7x. This is a 2x. It's a positive 2x, so don't be confused by the negative behind it. That negative belongs to the 3. This is a positive 2x, so I need to subtract 2x on both sides to get rid of it, because 2x minus 2x becomes nothing. Okay? Keep in mind, if you were to accidentally add 2x to both sides, you wouldn't cancel it out, because you would get 2x plus 2x, which is 4x, and we didn't get rid of it. We're trying to get rid of it. Okay, so always check to make sure you actually can get rid of it. 2x minus 2x, nothing. Left with the negative 3 on the left-hand side. Be sure to copy down that negative because it belongs to it. 7x minus 2x is 5x. Minus 18. Didn't touch that minus 18, so it's got to be brought back down. Okay, now all my x's are on the right-hand side, so my answer at the end is going to look like this, with the x's on the right-hand side. So we're going to leave that x alone for now, because we need to make sure our numbers are joined together on the left-hand side. So that means I need to move this minus 18, so I got to add 18 both sides, because negative 18 and a positive 18 cancel. So now I have negative 3 plus 18. Different signs subtract. 18 minus 3 is 15. Keep the sign of the bigger number, so it's positive. Positive 15 equals 5x. 5x means 5 multiplied by x. So the opposite would be to divide by 5. Those 5's cancel because one's on top, one's on the bottom. 15 divided by 5 is our answer, which is 3. So my answer is x equals 3, and I want to check it. 2 times x, which is 3, minus 3 should equal to 7 times x, or 7 times 3, minus 18. 2 times 3 and 7 times 3 need to be solved first, according to PEMDAS. So this is 6 minus 3 equals 21 minus 18. 6 minus 3 is 3. 21 minus 18 is 3. 3 equals 3. True statement, so that must mean that x does equal to 3. All right, so far we haven't worked on any problems where we actually do anything with the first step. So let's take a look at an example where we do. Go ahead and pause the video and try it on your own first. All right, so first step, like we said, is to take a look at each side and see if we can combine any like terms. We'll take a look at the left-hand side. Can we combine 16 minus 2t? Like, can we actually do anything with that? The answer is no, because one doesn't have a t and one does have a t. They're not like terms. Let's take a look at our right-hand side. Can we do anything? Can we combine any like terms? Here, yes, because on the right-hand side, I have a t and a 4t, so I can actually combine those together. So I'm going to rewrite the left-hand side and just don't touch anything there. Over here, I have a 1t plus a 4t, so we can combine that to make a 5t and then plus 9. Okay, so you always want to check both sides to see if there's anything you can simplify and combine together first to make your life a little easier. All right, now we'll continue to the second step like before. We'll move our variables and our constants around. I'm going to add 2t to both sides because this negative 2 is smaller than that 5. So I'm going to have it join this side by canceling out over here because they're opposites, negative and positive. 16 is left over. 5t plus 2t is 7t. So remember, if they're on the same side, you can just combine them like normal. T plus 4t is 5t. If they're on the opposite side, I can't just subtract 2t from this 5t here because it's on the opposite side. So I need to perform the inverse operation because they're on different sides of my scale. If they're both on the same sides, great, combine them. They're on the same side. Moving them closer together won't do anything to our scale, right? It's still on the same side. But once I take something away from the right-hand side or the left-hand side, it's gonna affect the balance of my scale. So again, if it's on the same side, no problem, do normal math. But they're on opposite sides, now you're talking about the weight that you need to balance out on your scale. Because remember, we have to keep them equal. Okay, so if they're on opposite sides, you gotta perform opposite operations. All right, so that's why we added 2 t's to both sides to cancel out the left-hand side. We get 16 left over equals 7t, because they're on the same side here, so we can just add them normally, plus 9. All right, so now my t's are gonna be on the right-hand side, so that means my numbers need to join on the left-hand side. I gotta subtract 9 on both sides to cancel it out over here. 16 minus 9 is 7. 7 equals 7t. 7 is being multiplied to t, so I gotta divide it both sides. 7 divided by 7 cancels out to 1. 7 divided by 7 cancels out to 1, not 0. This is not 7 minus 7. This is 7 divided by 7. 7 divided by 7 is 1. So t equals 1. Let's check it. 16 minus 2 times 1, terrible parentheses, equals 1 plus 9 plus 4 times 1. Okay, so this is really 16 minus 2. This is 1 plus 9 plus 4 because multiplying by 1 doesn't do anything. 16 minus 2 is 14. 1 plus 9 is 10. 10 plus 4 is 14. Yep. So my answer really is t equals 1. Okay, so again, if there are any like terms you can combine first on either side, do that first.